All right. So book assignment, and then there's going to be a review. I'll hand it out tomorrow.
And then test is on
Thursday. Thursday is going to be your test. And I'll talk. Yes,
Okay.
I'll talk later on what that's going to look like because I haven't fully decided yet. So.
Let's take a class test. Yeah, like together. That'd be so fun. But Mary and Eleanor can answer
Yeah,
our
it'd be
questions.
so fun to
I
help
won't
you
be good
guys
at that.
carry me. Thank you.
Mary, don't say that.
It'd be so fun to get a good grade, guys.
You're not allowed to.
I'm sorry.
All right.
I mean, it would be so fun to take initiative
We-
and help my class out.
Yes. Tell them what Aiden's not to say.
Yeah, yeah.
Everything that Aiden says.
Everything that I says is right. You guys are just like, guys, that's not the right answer. Avoid.
All right. Continuing.
You know what the thing that goes in?
Continuing.
Sorry.
So far, we have talked about when to tell whether something is linear or not linear. And so now we're going to, this last section is going to expand on that and talk about when our model is not linear, what does that look like? And how does that, and how can we still try to establish patterns and relationships between the variables? So we are going to, we're going to focus here on power model first. And that's going to involve things taken to a certain power. So, for example, if things involve a certain power that we know, like, area of a circle being pi r squared, let's say, then we would expect a quadratic relationship to be happening there. But another way that we can say that, so that we would have like this like y equals like x squared type of thing happening, a parabola type of thing happening. The other way of saying that is if I were to graph y versus x squared, then I would expect a line. So if I were to graph y and x squared on the scatter plot, then I would expect a linear pattern if something has a quadratic relationship. Because usually we would have a table that looks like this. Here's xy comes up here. So xy. Usually I'd have a table that looks like this. 1, 2, 3, 4, 5. And I would have, for y equals x squared, I'd have 1, 4, 9, 16, 25, etc. Yes? Now, if instead my table involved, instead of y and x, I graphed y and x squared, okay? So when I plug in 1, I still have 1, 4, 9, 16, 25. But then since I put x squared on this end of the table, 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25. And I just get like a straight line. Because this is basically going to be like it's going to look like a y equals x straight line. So I have a linear relationship between y and x squared. So if I just put the data squared in, I'm going to get a straight line. So it is basically taking a curved set of data and applying what we call a transformation to it to get a straight line in the set of data. So that's what we are going to see in these examples moving forward here. So go ahead and here comes some data to put in lists 1 and 2. Have at it.
Both of the length lines.
Yes. Length is your x. First off, let us go into stat plot and see what the scatter plot looks like. Make sure it's list 1 versus list 2. Mine was not, so we're going to make sure list 1 versus list 2, and we're going to go zoom 9. And it appears we do not have a line. So let's fix that. So what we're going to do, there are two different things that you can do on the calculator. So the first way that you can do this is that this turns out, if I kind of look ahead on the next slide here, this turns out to follow a cubic model. That's just how it turns out to be. So what I'm going to do is that instead of graphing x versus y, I'm going to do the same thing I did over on that table, and I'm going to graph x cubed versus y. So I'm going to go into stat. I'm going to go into my list. So here's my list 1. So I'm going to instead of using x, I'm going to use x cubed. So I'm going to take all my x coordinates, which are in list 1, and I'm going to cube them and put them in list 3. Hit enter. Okay, there is x cubed. So now my x list.
Mr. Hoffman.
1 second.
Things are going wrong on my calculator.
Okay.
Bad things.
Let me do this, and then I will go around and help. So now my x list, my x cubed, is in list 3. And so hopefully when I go to zoom 9, now it looks like a line. A linear pattern between list 1 and list 3.
I made it work.
All right. So next step, get some equations. We can get some equations from stat and calc. So the first way I'm going to do this is with my linear regression and figure out what the equation of the line that I just made is. Not this. Okay. There we go. And remember, this was graphing list 3 versus list 2. Yeah, I'll go ahead and store my regression equation into y1. And calculate. Notice my r squared is very close to 1. So very strong linear association here. And then if I go to zoom 9, I'm going to be able to graph it. Now, what that equation is going to look like, remember that I graphed y versus x cubed. So this is y hat equaling 4.0658 plus 0.014677 x cubed. Remember, we graphed x cubed on the x-axis and y on the y-axis. So that's one estimation for the equation. Now, when I went into my stat calculate menu, you may have also noticed that there was one that was called cubic regression. So since I know this follows a cubic pattern, I can go into the calculator, and now I'm graphing list 1 versus list 2. I'm not going to store this equation. I'm just going to show you what this looks like. And it follows this format. So it is fitting an x cubed model to this. So this is a slightly different equation. Instead of following a plus bx cubed, it follows your usual standard form for a cubic model. So this would be 0.014 x cubed plus 0.016x squared plus 0.65x plus minus 7.229. So those are the two different ways. And there are a couple of others. There's a quadratic regression one. There's a couple of others that we'll be looking at in the next couple of examples. But that is another tool that is there. And once again, r squared, 0.99. Very strong. That tells us a cubic model is a good fit for this data. This set of data. All right. So this is going to show all those ideas again here, but with more plots. The other way you can do this is instead of graphing x cubed versus y, you could go the other way and graph x versus the cube root of y. That'd be the same thing. It's just taking the cube root of both sides. So you would put, in list 3, instead of putting x cubed, you would put the cube root of y. So cube root of list 2. And that would be what I would put on the y-axis. And both of them give the regression lines. This one on the left is the one that we did. If you made the residual plot of that, here's what it would look like. If you made the residual plot and made the equations with x and cube root of y, that's what these would look like. So equations of those regression lines, we just wrote those down. Remember that whatever we put on that left side for y, we're going to put a hat on it. This is the main one that we just wrote down. Remember that when you put equations down, you either can just write out the variables in words like this, or you can write it this way with y hat and x, and then you would need to say here's what x is and here's what y hat means, and like defining those two variables. Okay. Now there's a couple more parts to this, but I want to jump ahead here to kind of introduce and get into your head the next thing we're going to look at tomorrow. Okay, so we're going to do this tomorrow, but I want to jump ahead and talk about how this chapter is going to use logarithms. Exponential model. If y equals ab to the x. Here we go. Exponential model. We're going to be using a couple different properties of logarithms here. If we take the log of both sides. First thing that can happen here, watch closely here, take the log of both sides. First thing that I see is that I have multiplication going on inside the logarithms. When I have multiplication going on inside the logarithms, then I can split that apart with addition. That's a property of logarithms. That the log of AB is the log of A plus the log of B. Log of A times B is the log of A plus the log of B. The next thing I see is that I have an exponent happening inside of the logarithm. And you should know that anytime we have an exponent happening inside of the logarithm, I can take that exponent and bring it out in front of my logarithm. And so here is, and so the main thing that you'll need to know is that if I have exponential is that on the x-axis is going to be x, and on the y-axis is going to be the log of y. And that comes from these properties of logarithms that you should hopefully know. Okay, so we'll talk more about that. We'll talk more about that tomorrow and build these logarithm equations.